Today we're talking about limiting reagents. A limiting reagent is the reactant that is present in the smallest stoichiometric quantity in a mixture of reactants. The amount of product that can form is limited by the complete consumption of the limiting reactant, which is a fancy way of saying that whatever finishes first stops the reaction while keeping track of the stoichiometry. So to make a simple example, if one meal is composed of a slice of pizza and a drink, how many meals can be prepared with 5 slices and 4 drinks? The answer is 4 meals can be prepared. The limiting reagent is the drinks. If you only have 4 drinks, you can only prepare 4 full meals with 1 drink each and 1 slice of pizza each. To move on to an example that involves chemistry, we can look at an example from our textbook. It's exercise 372 from Brown. It shows the reaction of aluminum hydroxide with sulfuric acid to produce aluminum sulfate and water. And we're told that 0.5 moles of each of these 2 reagents is reacted together, and then we're asked to find out which one is going to stop the reaction. Sulfuric acid is being used at a faster rate. You see that for every 2 moles of aluminum hydroxide being used, we need 3 moles of sulfuric acid. So because this is being used at a faster rate, but they're present in equal amounts, then the sulfuric acid is going to finish first. Sulfuric acid is being used at a faster rate according to the balanced equation. And here's the important thing. The equation has to be balanced before you try to answer any questions relating to which is going to finish first. Since both reagents are present in equal amounts, the one that is being used faster will finish first. Sulfuric acid finishes first and stops the reaction. So sulfuric acid is the limiting reagent here. In the next question we're asked, how many moles of aluminum sulfate will be produced? Well, the stoichiometry between sulfuric acid and aluminum sulfate is 3 to 1, and that's why we have this conversion factor here. We start off with 0.5 moles of sulfuric acid. The calculation starts from what we find out is the limiting reagent. We've established that sulfuric acid is the limiting reagent, so we're going to multiply by the stoichiometry of the reaction between aluminum sulfate and sulfuric acid to find out that it produces 0.16 recurring moles of aluminum sulfate. In the next step, we're asked how much aluminum hydroxide is going to be used. These are both these are both reactants. This is the limiting reagent. So we're going to use, we have 0.5 moles of sulfuric acid available. We include the stoichiometry to find out that only 0.3 moles of aluminum hydroxide are used under the same circumstances. So once 0.5 moles of sulfuric acid is used, only 0.3 recurring moles of aluminum hydroxide has been used. And the question asks us how much is left. So we subtract 0.3 recurring from 0.5 to find out that 0.16 moles of aluminum hydroxide is left over. In question 3.73, we're asked to solve for the limiting reagent in the 2 ingredients that make up Alka-Seltzer tablets. We're told that there's 1 gram of sodium bicarbonate and 1 gram of citric acid in each tablet. Which one of these 2 is the limiting reagent? So the first step is to find out how many moles we have of each one of these substances. So the denominator of this expression contains the molar mass of sodium bicarb, and the denominator of this expression contains the molar mass of citric acid. We find out that there are 0.011 moles of sodium bicarbonate and 0.005 moles of citric acid. The stoichiometry of the reaction, however, is 3 moles of sodium bicarbonate for every 1 mole of citric acid. So as it turns out, when we do the calculation to find out which one the limiting reagent is, even though this one has more moles, it is nevertheless limiting because of the stoichiometry, which is 3 to 1. And we show that here. We start off with the 5.2 times 10 to the minus 3 moles of citric acid. 3 moles of sodium bicarbonate used for every 1 mole of citric acid means that we need 0.0156 moles of sodium bicarbonate, but we only have 0.011 moles of sodium bicarbonate. So the sodium bicarbonate is limiting. That's why I put a little unhappy face there. That doesn't mean we're unhappy with the fact that sodium bicarbonate is limiting. It just helps us remember. We continue our calculation with the sodium bicarbonate, because it is the limiting reagent. It's going to stop the reaction, to find out how many moles of CO2 is produced. And the stoichiometry between the production of CO2 and the usage of sodium bicarbonate is 3 to 3, which is essentially 1 to 1. Then we multiply by the molar mass of carbon dioxide to obtain how many grams of carbon dioxide are produced. We're only allowed 3 significant figures to report our answer, so we get 0.5 to 4 grams of CO2 is produced. In part C, we're asked how many moles of citric acid is left. So again, we start the calculation with the sodium bicarbonate. We include the stoichiometry. That's how many moles of citric acid is used. This is how much we have. Used minus what we have equals how much is left. And then we take how much is left, multiply by its molar mass to tell you how many grams of citric acid is left at the end, and then we report it to 3 significant figures. 0.238 grams of citric acid is left at the end of the reaction.